All right, buckle up, everyone, because today we're taking a deep dive into four-dimensional space.
Ooh, sounds like a head spinner.
It definitely is. You know, you tossed us a pretty fascinating mix here, excerpts from Wikipedia's four-dimensional space entry
Classic.
and an article called The Visual Appearance of Higher Dimensional Objects.
I like where this is going.
Clearly, you're ready to move beyond just length, width, and height, so we're going to explore what 4D space might actually look like if we could perceive it.
Yeah, that's the big question, isn't it? I mean, we can talk about the math all day long, but how do you actually picture something that's beyond our three dimensions?
Exactly. So, to really grasp this, we need to start with a solid foundation.
Okay, foundations are good. Where do we begin?
It's easy to assume that when we talk about 4D, we're talking about Einstein and, time being the fourth dimension.
Right, that's usually the first thing that comes to mind.
But it's actually much bigger than that. Four-dimensional space is a geometric concept that's been around much longer than Einstein's theories.
Oh, really? How far back are we talking?
Think mid-1800s, like a time when horse-drawn carriages were still the main mode of transportation.
Whoa, okay, so way before smartphones and the internet.
Exactly. Back then, there was this Swiss mathematician named Ludwig Schläfli.
Schläfli. That name rings a bell.
He was already exploring the geometry of higher dimensions.
Wow, so this idea's been brewing in mathematics for a while then.
Over a century and a half. What's fascinating is that Schläfli's work laid the foundation for our understanding of higher dimensional geometry today.
So he was like a 4D pioneer.
Absolutely. He even figured out the 4D equivalents of the Platonic solids.
Platonic solids. Refresh my memory on those.
Those are the perfectly symmetrical 3D shapes, like cubes, tetrahedrons, octahedrons.
Ah, right, those perfectly balanced shapes.
Hmm.
So Schläfli was figuring out what those would look like in 4D.
Precisely. But even with all the math, visualizing 4D can still feel impossible.
You're telling me. So how do we even begin to picture a fourth spatial dimension?
Well, that's where things get really interesting. Around the turn of the 20th century, long before the concept of 4D really entered popular culture,
Okay.
there was this guy named Charles Howard Hinton who dedicated himself to this challenge.
So he was like a 4D popularizer, trying to make it accessible.
Exactly. He even coined terms like tesseract for a 4D cube
Yeah.
and came up with methods to try and represent these objects.
I've definitely heard of a tesseract before. It's like
Good.
the mind-bending 4D version of a cube, right?
You got it. And to understand his approach, we need to think like a two-dimensional being. Imagine a Flatlander living on a completely flat plane.
Okay, I'm picturing a little square dude sliding around on a piece of paper.
Perfect. Now imagine a sphere passing through that flat plane. What would the square see?
Let's see. You would see a point appear, then grow into a circle, reach its maximum size, and then shrink back down to a point before disappearing entirely.
Exactly. To the Flatlander, it would seem like magic, a shape appearing and disappearing out of nowhere.
But from our 3D perspective, we understand that it's simply a sphere passing through a 2D plane.
Precisely, and that's the key to understanding how 4D objects might appear to us.
So are you saying a 4D object passing through our 3D space might appear and disappear in a similar way, like a ghost or something?
That's the idea, just like the sphere popping in and out of existence for the Flatlander.
Whoa.
A 4D object might seem to defy our understanding of physics as it intersects with our world.
Okay, that's already blowing my mind a little.
Yeah.
But how do we move beyond just points appearing and disappearing? How do we actually picture the shape of a 4D object?
Well, to do that, we need to talk about superellipses, which might sound complicated, but just think of them as a visual tool that helps us bridge the gap between familiar 3D shapes and the mind-bending forms of 4D objects.
All right, I'm all for simplifying things. Give me the superellipse 101.
Think of a circle. Now imagine gradually squishing it in so its sides become flatter and flatter.
Okay, I'm with you.
Eventually, with enough squishing, it starts to resemble a square with rounded corners. Ah, so it can morph between a circle and a square. Interesting.
Right, and this same concept can be extended to 3 dimensions, where we can use superspheres to transition between spheres and cubes.
And this is how we start to picture a 4D object.
Exactly. It lets us go beyond just looking at tesseracts, which is what we call the 4D cube, as those wireframe outlines we often see.
So we can start to get a sense of their volume, how they actually fill space, even if it's a space we can't fully see.
Precisely. And it's this understanding of volume that allows us to start visualizing some truly mind-bending concepts. Imagine a 4D supersphere rotating in a way that affects this 3D cross-section. Hold on, I need a visual here. Are we talking about those animations where a tesseract seems to turn itself inside out? I've seen those online, and they always make my head spin.
That's one way to think about it. The article we're looking at describes specific visuals, like an octahedron shrinking and growing, or a cube seemingly transforming into a rectangular solid,
Right.
all through 4D rotation. It's like watching a shape-shifting magic trick, but it's all based on geometry.
Okay, this rotation thing is really messing with my brain. It's like the shape is changing, but it's not. I think I need a minute to process this.
It's a lot to take in, I know, but what's fascinating is that to a 4D being, these rotations would be perfectly normal and symmetrical.
Completely.
It's our limited 3D perception that makes them seem so strange.
So we're like those Flatlanders staring up at a cube passing overhead, completely baffled by what we're seeing.
Exactly. We can only glimpse the shadows of 4D objects, but even those shadows are enough to spark our imaginations and challenge our understanding of reality.
This is where I start to feel like I'm falling down the rabbit hole.
Yeah.
So if we can't fully grasp 4D, how do we even begin to understand its implications or applications? Well, it's true. Trying to wrap our heads around the implications of 4D can feel like, I don't know, trying to hold water in your hands.
It definitely feels that way sometimes, like it's just slipping through my fingers.
Exactly.
Yeah.
But that's also the beauty of it, right?
Mhm.
Even our limited understanding can open up a whole new universe of possibilities.
I like the way you think. So where do we go from here? How do we push past those limitations and actually, delve deeper into this 4D world?
But we've talked about these rotations and cross-sections.
Right.
But it's important to remember that they all stem from our 3D perspective.
Right. We're trying to squeeze a 4D object into our 3D world, so we're forced to look at it in slices.
Yeah, it's like examining a loaf of bread one piece at a time. You get a sense of the texture, maybe some of the ingredients, but you're missing the whole picture. Literally.
But that's not the whole loaf. We're missing the bigger picture.
Exactly. And that's the challenge with visualizing 4D. Think about those animations of the rotating tesseract.
Okay.
When it appears to change shape, a 4D being wouldn't see that at all. To them, the shape is constant. It's only our limited perspective that makes it seem like it's morphing.
So how do we get closer to that 4D being's perspective? Is there any way to move beyond these glimpses and see the whole 4D object at once?
That's the million-dollar question. And honestly, it might be beyond our capabilities. But the article does suggest some intriguing ways to enhance our visualizations.
Ooh, I'm all ears. What kind of enhancements are we talking about?
Well, one idea is to use color coding to represent the interior of a 4D object. Imagine taking a tesseract and coloring each of its 8 cubical cells a different color.
Okay.
Then, as it passes through our 3D space, we could see how those colors slice through, giving us a better sense of how the whole object is oriented.
Hold on. I'm trying to wrap my head around this color coding idea. Wouldn't it still be a 3D projection? How would we actually see the inside of a 4D object?
You're right to question that. It wouldn't be a perfect representation, of course, because we'd still be limited to those 3D slices. But it would be a step closer to understanding how those slices relate to the whole 4D object. Think of it like looking at a CAT scan. You're seeing 2D images,
Right.
but they give you information about a 3D structure.
Okay, that makes sense. So it's less about seeing the whole 4D object at once and more about understanding how the parts connect.
Precisely. It's about building a more complete mental model of what a 4D object might be like.
It still sounds pretty abstract to me, but I can see how it would be helpful. What other ways can we enhance these visualizations?
Well, the possibilities don't stop there. We could also explore the shapes that would emerge if we added even more spatial dimensions. The article mentions that the math easily extends beyond 4D, which opens a whole new can of worms.
So we could have 5D superspheres, 6D hypercubes, and so on. I'm not even sure I can wrap my head around that. It's like trying to imagine a new color that doesn't exist.
It definitely stretches the limits of our imagination. But even if we can't fully visualize those higher dimensions, thinking about their properties and how they might interact with our 3D space can be a fascinating thought experiment.
It's like each additional dimension unlocks a whole new level of complexity and strangeness.
Absolutely.
It makes you wonder what other dimensions might be lurking out there beyond our perception.
That's a question that has puzzled physicists and philosophers for centuries. And who knows? Maybe someday we'll develop new tools and technologies that will allow us to visualize these higher dimensions in ways we can't even imagine right now.
It's both exciting and a little terrifying to think about, isn't it?
Absolutely. But even if we never fully grasp the complexities of higher dimensions, just the act of trying to understand them expands our thinking. and forces us to confront the limitations of our perception.
Okay, I'm feeling a little overwhelmed, but in a good way. I need a minute to let all this sink in.
I think that's a natural reaction when you're grappling with concepts that challenge our fundamental understanding of reality.
It definitely is. But even though it's complex, there's something so captivating about exploring these ideas.
Yeah, it's like we're peering into the unknown, trying to catch a glimpse of something beyond our grasp.
And that's what makes it so intriguing. It's a reminder that there's always more to learn, more to discover, even if it bends our minds a little along the way.
You hit the nail on the head. But before we get too lost in the abstract, let's bring it back to you, the listener. What stands out to you from all of this? What's the most mind-blowing or intriguing aspect of 4D space so far?
Yeah, take a moment to think about that. And while you're pondering the mysteries of higher dimensions, we'll wrap things up with a final thought that's been swirling around in my mind. So, we've spent this deep dive exploring how to visualize 4D objects, but what about movement? What would it look like for a 4D being to move through our 3D space?
Hmm, that's a question that really pushes the boundaries of our imagination, doesn't it? Let's go back to our trusty Flatland analogy for a moment.
Okay.
Imagine a 3D being, like a sphere, moving through the Flatlander's plane.
Okay, I'm picturing that little square dude again, watching a sphere pass overhead.
To the Flatlander, it would look as if the sphere was constantly changing size,
Right.
growing and shrinking, even though, from our perspective, it's simply moving in a straight line.
So if a 4D being moved through our space, would it look like it was constantly changing shape and size, even if it was maintaining a consistent form in its own dimension?
Exactly. We might only see parts of it at any given time, with sections appearing and disappearing in ways that seem to defy our understanding of physics.
Wow.
Imagine a 4D creature walking through a wall.
Okay.
To us, it would look like it vanished into thin air, only to reappear on the other side.
Wait, wouldn't we see more than just parts appearing and disappearing? Wouldn't there be some kind of trace or distortion as it moved through the wall?
That's a great question, and it really highlights how much we're still grappling with these concepts.
Hmm.
Our intuition tells us there should be some kind of evidence of its passage.
Right.
But in reality, we might not see anything at all. Or perhaps we'd see something completely unexpected, something that breaks our current understanding of physics.
Now that you mention it, I remember reading somewhere that some physicists believe gravity might be a force leaking from a higher dimension.
Oh, interesting.
Could that tie into what we're talking about here?
It's certainly an intriguing possibility, and it speaks to the fact that 4D isn't just a mathematical abstraction.
Yeah.
It might actually be woven into the fabric of our reality in ways we're only just beginning to understand.
Okay, my head is officially spinning, but this is the kind of mind-blowing stuff that I love to explore.
It's a reminder that even in our technologically advanced age, there are still mysteries that lie beyond our grasp, and that's a beautiful thing.
It really is. So what does this all mean for you, the listener? We've thrown a lot of information at you, from flatland analogies to shape-shifting tesseracts. The key takeaway here is that our universe might be far more complex and wondrous than we can currently perceive.
Right.
The next time you look at a simple cube, try to imagine it from a 4D perspective. With all its faces and insides visible at once, it might just change the way you see the world around you.
And remember, this is just the tip of the iceberg. We only scratched the surface of visual exploration. Imagine color-coding the interior of 4D objects to see how they slice through our space, or explore the bizarre shapes that would emerge if we added even more spatial dimensions. The journey into higher dimensions has just begun.
And who knows, maybe someday our understanding of physics will advance to the point where we can actually detect or interact with these higher dimensions. That would truly revolutionize our understanding of the universe.
It would. Until then, we can keep exploring, keep imagining, and keep our minds open to the infinite possibilities that lie beyond our current perception.
That's a great note to end on. Thanks for joining us on this deep dive into four-dimensional space. It's been a wild ride.
It was a pleasure exploring these mind-bending concepts with you.
We'll catch you next time on The Deep Dive, where we'll continue to explore the most intriguing and thought-provoking ideas out there.